Hello everyone. This video would focus on conic section, specifically on parabola with vertex at HK. And this is the first part. In this part, we're supposed to sketch the graph, determine the vertex, focus the length of the latus rectum, equation of the directrix, the line of symmetry of a given equation. Before we jump into this example right here, let's have a review on the basics of parabola with vertex at HK. We remember that there are 4 cases of a parabola with vertex at HK. But before we dive into these 4 cases, let's have the parts of every parabola. The first part that we need to remember is the vertex. So this is located right here. So this is our vertex, and this is actually represented at HK, coordinate HK. Another part that we have is the focus. So this is our focus right here. Now we remember that the location of the focus from the vertex determines where the parabola opens. If the focus is located to the right of the vertex, that means that the parabola will open to the right. On the other hand, if the focus is to the left of the vertex, then the parabola opens to the left. We also remember that the distance from the focus to the vertex is represented as P. And this is also P right here. Another part is the ends of the latus rectum. So these 2 points that we have here are the 2 ends of the latus rectum. We need these 2 ends in order that we can graph the parabola from the vertex. Okay, now we remember that the distance from the focus to one end of the latus rectum is 2p. So I'm going to go ahead and write that up here. We also remember that this value of p here, which is from the vertex to the focus, this value right here will be negative. The reason for that is because it's going to the left. While on the other one right here, the value of the p is positive because it's going to the right. Now, another part that we need to remember is the directrix. So this is the directrix right here, represented in a broken line. Now, we also remember that the distance of the directrix from the vertex is also P. So I can go ahead and label that up here. This tells us that the vertex is actually in the middle between the point where the directrix passed through and the focus. So the vertex is in the middle of these 2 points. Another part of the parabola is the line of symmetry. The line of symmetry will always pass through the focus and the vertex. So this is our line of symmetry. On the right, you will see the first case. I labeled it as case 1, and that is when the parabola opens right. And while case 2 is whenever the parabola opens to the left. For these 2 cases, the equation that we are going to use every time will be quantity y minus k squared equals 4p quantity x minus h. So this is the equation that would work for these 2 cases. We remember that the sign of the p matters between these 2 graphs. Whenever the p is positive, it opens to the right. Well, if the p is negative, it will open to the left. So they're pretty much the same thing, but the p matters because it determines where the parabola opens. Now let's have the third and the fourth case. The parts of the third and the fourth case are pretty much the same thing. We have the vertex. We also have the focus. Now, looking at this for case 3, since we again remember that a parabola opens towards where the focus is from the vertex. Since from here, our focus is located above the vertex, then the parabola opens up. In this case right here, since our focus is below the vertex, then that means that the parabola will open down. Again, we remember that the distance from the vertex to the focus is represented as P. And so from here, we can go ahead and say that the P value here is positive because it's above the vertex, while the P here is negative because it's below the vertex. Now, the other parts would be the ends of the latus rectum. So we're going to need these 2 points together with a vertex so that we can sketch the parabola. Now, we remember that the distance from the focus to the end of the latus rectum is 2p, and this is also 2p. The same thing for this one right here. This is 2p and 2p. Another part is the directrix. We remember that the directrix is always located opposite to the focus from the vertex. So it's going to be opposite to the focus from the vertex. And then we also have another part here is the line of symmetry. So the line of symmetry is a line that passes through the focus and the vertex. For cases numbers 3 and 4, the general equation of the parabola would be quantity x minus h squared equals 4py minus k. This is the formula that would work for these 2 cases. Case number 3, when the parabola opens up, and case number 4, when the parabola opens down. We remember that if the P is positive, then it opens up. And when the P is negative, then the parabola opens down. Okay, going back to the problem right here, we're supposed to determine the coordinates of the vertex, focus, ends of the latus rectum, equation of the directrix, and the line of symmetry, and we're supposed to sketch the graph of this given parabola or equation of the parabola right here. There are steps that we need to follow in order that we can determine all of these variables here and in order that we can sketch the graph here. The first step is to determine and plot the vertex, HK. So in this case right here, we have this represents our H and this represents our K. So we are going to write the coordinate of the vertex here. We remember that the trick here is to switch the sign and switch the sign. So that means that the vertex is located on -3 and +1. So this is the location of the vertex. Switch and switch. So the vertex is on -3, 1. So I'm going to plot that up here. So it's 1, 2, 3, and 1. So this is our vertex. So I'm going to go ahead and label this as V. The second step is to solve for P, determine where it opens, determine the case number, and determine and plot the focus. So in this case right here, we remember that this 8 that we have here represents 4P. So that we go ahead and solve for P from here. We can go ahead and say and write that 4P is equal to 8. So 4P is equal to 8. So we're supposed to solve for P. So we're going to divide both sides by 4, divide this by 4. So then we can go ahead and say that our P is 2. We can see that the value of P is positive. This tells us that the focus is located 2 places above the vertex. So I'm going to go ahead and write that up here. The reason why the focus is above the vertex because we have a positive P. So that we can go ahead and locate the focus here. So that's going to be 2 places from the vertex. 1, 2. So this is where the focus is going to sit. So I'm going to label this as F. So the coordinate of the focus is -3, 3. So I'm going to write that up here. -3, 3. From here, we can tell where the graph opens. We remember that the graph opens towards where the focus is from the vertex. Since the focus is located above the vertex, this tells us that this parabola opens upward. So I'm going to go ahead and write that up here. Since our parabola opens upward, this is an example of case number 3. Okay, the third step is to determine the two ends of the latus rectum and sketch the graph. Now we remember that one end of the latus rectum has a distance of 2p from the focus. So I'm going to write that statement up here. So on the side, I've solved the value of 2p and it's 4. Again, we remember that one end of the latus rectum has a distance of 2p from the focus. So we're going to count 4 spaces from the focus left and right, since again, our parabola opens up. So I'm going to count 4, 1, 2, 3, 4. So this is where the first latus rectum is gonna sit, and we count also 4 to the left. 1, 2, 3, 4. This is where the second end of the latus rectum is gonna sit. So we can go ahead and say that the ends of the latus rectum are on -7, 3 and +1, 3. So I'm gonna go ahead and write the coordinates of the ends of the latus rectum right here. So we can go ahead and sketch the graph of this parabola. Okay, so then we go ahead and move on to the fourth step. We're supposed to determine the directrix and the line of symmetry. Before we go into that, we remember that we also need to determine the length of the latus rectum. The formula for the length of latus rectum is 4p. So then we go ahead and say that since our p was 2, so we plug it in. 4 times 2 is 8. So this is the length of the latus rectum. So from one end to the other end is 8. So if we count it, 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 spaces. Now we're ready to sketch the directrix. We remember that the distance of the directrix from the vertex is P. So since our P was 2, so we go down 2 down below. So this is where our directrix is gonna sit. So the equation of the directrix is y equals -1. So I wrote that up here. Now we remember that the line of symmetry is a line that connects the focus and the vertex. So I go ahead and draw the line of symmetry right here. So the equation of the line of symmetry is x equals -3. Now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. We're supposed to determine the vertex, focus, length of latus rectum, equation of the directrix, and the line of symmetry of this equation that we have right here. Again, we have steps that we need to follow. The first step is to determine and plot the vertex HK. We remember that our HK can be gotten from the equation. So in this case right here, our H goes with X every time. So this is where the H is going to sit next to it. And then our K is next to the Y. So this is our K right here. Since there is no value of H here, since this is pretty much like X minus 0, so we can go ahead and say that our H is 0 and switch this. So it's going to be -3. So then we go ahead and plot that down here. So 0 and -3 is gonna sit down below. So this is our vertex. Now we're ready to move on to the second step. The second step is to solve for P, determine where the graph opens, determine the case number, and determine and plot the focus. So we remember that this coefficient that we have here of this quantity is, where in this case it's -10. This is actually our 4p. So that from here we equal these to each other and solve for p. I will show the work on the side right here. The p value that we have here is -5/2. This tells us that our focus is located below the vertex, since this kind of equation works well with case 3 and 4. So then we can go ahead and write that down here. Okay, the reason why this is below the vertex because the sign here is negative. And since we say that this is negative here, this tells us that this graph opens down. And we can tell that as well here because we remember that our parabola will always open towards where the focus is from the vertex. Since our focus is below the vertex, so then we can go ahead and say that our parabola opens downward. So I'm going to go ahead and write that up here. So what I did here was that from the vertex, I go down 5/2 is 2.5. So I go down 2.5 steps from the vertex. So 1, 2.5. So this is the location of the vertex because again, the distance from the vertex to the focus is P, so that we can go ahead and write the coordinate of the focus. So the focus is located at 0, -5.5 or 0, -11/2. So we're ready to move on to the third step. The third step is to determine the two ends of the latus rectum and sketch the graph. We remember that one end of the latus rectum has a distance of 2p from the focus. I'm going to go ahead and write that up here. The value that we got is 5. This tells us that we go 5 steps to the left and 5 steps to the right to plot the ends of the latus rectum. So I'm going to go ahead and write the coordinates of these two ends of the latus rectum, so that we can go ahead and sketch the graph, and this is how it's going to look like. So this graph right here has an equation of x squared equals -10 quantity y plus 3. We can go ahead and determine the length of the latus rectum. From here, we remember that the formula for the length of the latus rectum is 4p. So 4 times 5/2, that gives us 10. So the distance from this end to the other end is 10 units. Now we're ready to move on to the fourth step. The fourth step tells us that we're supposed to determine the directrix and the line of symmetry. We remember that our directrix is located across from the focus relative to the vertex. So if this is 2.5 or 5/2, we go up 5/2 units as well. So this is where our directrix is gonna sit. And our line of symmetry is again the line that passes through the vertex and the focus. So I can go ahead and draw that line up here. Did you get the same answers as this? Good. Perfect. Now let's move on to the third example. Okay, so we go over this next example right here. So we are given this equation and we're supposed to determine the vertex, focus, length of the latus rectum, equation of the directrix, and the line of symmetry. There are steps again that we need to follow. The first step is to determine and plot the vertex HK. So in this case right here, this represents our H and this represents our K. Remember that the H goes with X and the K go with Y. And so we go ahead and switch and switch. So that gives us a +2 because it's negative, switch, positive. +1, that would be a -1. So this is our, or the coordinate of the vertex. So we go ahead and plot that down here. So that's gonna be 2, +2, and -1. So this is where the vertex is located. So I'm going to label this as V. Now the second step is to solve for P, determine where the graph opens, determine the case number, and determine and plot the focus. So we remember that this value coefficient that we have right here represents our 4p, so that from here we can go ahead and solve for p. I'm going to show that work on the side right here. The value of p that we have here is positive. This tells us that since this is this equation that we have right here would work for cases numbers 1 or 2, we can tell that since this is positive, our focus is to the right of the vertex. I'm going to write that up here. The reason why it is right of the vertex because that is positive. And this formula works for cases 1 and 2. So that we can go ahead and plot the focus here. So our focus again will be located 3 spaces to the right. So I count 1, 2, and 3. So this is where our focus is gonna sit. And that tells us that the coordinate of the focus is 5, -1. So that's 5 and -1. Now we're ready for the third step. The third step is to determine the 2 ends of the latus rectum and sketch the graph. We remember that one end of the latus rectum has a distance of 2p from the focus. So we go ahead and write that statement up here. So the value that we got here is 6. This tells us that from the focus, we go up 6 spaces and down 6 spaces to draw the 2 ends of the latus rectum. So the 2 ends of the latus rectum is 5, 5 and 5, -7. So we're ready to sketch the graph. So this is how the graph is going to look like. So this is the graph of this equation that we have right here. We remember that we can determine the length of the latus rectum from here. The formula is 4p, so that is 4 times 3 is 12. So if we count the distance from one end to the other end of the latus rectum, it's going to be 12 units. Now let's move on to the fourth step. The fourth step is to determine the directrix and the line of symmetry. So we remember that our directrix is located p units across the focus from the vertex. So if this unit right here is 3, so we go to the other side 3, and I'm going to draw the directrix. And the line of symmetry is the line that connects the focus and the vertex. I'm going to draw that up here. And we have solved this problem that we have right here. Now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. Again, our first step is to determine and plot the vertex. We remember that the vertex is represented as HK. So this is where our H is. It goes with a X, and this is our K. It goes with a Y. So this tells us that our vertex is located at 0 since there's no H value right there. So this is pretty much like X minus 0. And so the K value here is positive 3 because remember, we're supposed to switch. So it's a minus 3, that's a positive 3. So we go ahead and plot that vertex right here. So it's going to be at 0, 3. So X is 0, 3 is our Y. So it's going to sit here. So I'm going to label this as the vertex. Now let's move on to the second step. The second step is to solve for P, determine where the graph opens, determine the case number, and determine and plot the focus. We remember that this represents our 4P. So I go ahead and label this as 4P, and I will solve for the P on the side here. So the P value is -3/2 or -1.5. Since this equation that we have here resembles that of either case 1 and case 2, and we have solved the P as negative, this tells us that this is an example of case number 2, which tells us that our focus is to the left of the vertex. So I'm going to go ahead and write that up here. So I'm going to plot the focus here to the left of the vertex. 3/2 is 1.5. So it's going to sit here. That's 1 unit. And this is 1.5 units. So I'm going to label this as the focus. This tells us that this graph opens to the left because again, our focus is to the left of the vertex. So the parabola is going to open this way. So I'm going to go ahead and write that up here. Okay, so again, this opens to the left, and this is an example of case 2. Looking at this, our coordinate for the focus would be, that goes to the x here, which is -3/2 or 1.5 and then 3. So I'm going to write that up here. Now we're ready to move on to the third step. The third step is to determine the two ends of the latus rectum and sketch the graph. We remember that one end of the latus rectum has a distance of 2p from the focus. I'm going to write the statement up here. This tells us that we go up 3, down 3 from the focus to get the location of the two ends of the latus rectum. So that's 1, 2, 3. So this is the first end. And we have 1, 2, 3. This is the second end of the latus rectum. This tells us that these two are the ends of the latus rectum. And I'm going to write the coordinate of these 2 points. Okay, so we're now ready to sketch the graph. So this is the graph of this equation that we have right here. So we're now ready to determine the ends of the latus rectum. So the ends of the latus rectum is 4p. So that means 4 times 3/2. That gives us 6. So if we count the distance between these 2 points, that would be 6 units. Now we're ready to move on to the fourth step. Determine the directrix and the line of symmetry. We remember that the directrix is p units opposite to the focus from the vertex. So if this is 1.5 unit to the left, we go 1.5 unit to the right, and that is where the directrix will sit. So it's going to be here. I'm going to draw the directrix here. We also remember that the line of symmetry is a line that connects the focus and the vertex. So this is where our line of symmetry is going to sit. And so we have solved the problem. Did you get the same answer as this? Good. Perfect. If you found this video helpful, hit like and subscribe for more math videos. See ya!